Hi everybody. Yes, now we're gonna have a look on some power supplies. Yes, in front of the camera there we got one of my newly made power supplies. This is pretty nice. Yes, before that, if you remember that big PCB it could provide 24 volts, 25 amps. That one is inside this box now. Here we got some outputs. These are not variable. You can't actually adjust these. You need to actually remove the actual connector along this row here. Here we got 12 volts, 5 volts. That's our normal computer power supply. 3.3, negative 5 volts and negative 12 volts. Ground is here. And on the top part we got two 24 volts out and two ground for the 24 volt. So those two grounds are actually separated, but you can actually connect them together. And here's the on-off switch for that 24 volt power supply. And yes, this one actually goes up to just the highest voltage is 24 volts. If I want more than that, like a previous video with the slider exciter, I need to use that one. This little box. As I told that I need to connect a rectifier to it, and I have done that, so that's ready to go. There's a rectifier inside it and a smoothing capacitor, and it's almost done, or it is actually done. So let's have a look inside. So yes, here's what it looks like inside. It's maybe don't look so nice. The wiring is not so great. But this is actually a semi-variable output. It's actually not a variable output, not a smooth variable. It's very coarse. It's actually 12 volts, 44 volts, 70 volts, 100 volts and 130 volts. That's very, it actually jumps around. So yes, rectifier is here. Capacitor is a bit overkill. I didn't find any smaller capacitor. 450 volts. No chance that that capacitor will be charged up to 450 volts. 470 microfarad. There's a little fuse to protect it. A little smoothing capacitor for the relays. There's actually relays here that actually changes the tap. All taps are down here. There's a lot of outputs on that transformer. I'm going to turn it on, and let's have a look on the relays. This looks pretty nice. So now that LED is turned on, so actually goes around like that. So actually, I can select which tap I can take the voltage out. That's the first one, that's not connected, so 0 volts, 12 volts, 44, 70, 100 and 130 volts. And disconnected. There's a bleed resistor here to actually discharge the capacitor. Let's see if any charge left. No. That bleed resistor does its job. And there's this toroidal transformer, of course. Let's have a look on the other side. Here you can see some part of that connector block. Then toroidal, relays. And there's a selector switch. So let's put this back together and have some fun. Before I'm going to do anything, I will show you that these boxes, I have lots of these boxes, they're pretty nice. Like up here, we've got two more. That's actually a oscillator, and that's empty. I'm gonna build something in that. And down there's another one that was a high power, high frequency oscillator used for induction heaters and stuff like that. So I'm gonna have connected in the power supply. I have hooked up a little motor. That's an AC motor that actually kind of works on AC or DC, I mean. So let's crank up the voltage. So that's 12 volts. We go 44. It begins to rotate. 70. 100, or US voltage. Yes, US voltage. 130 volts. Or actually, if you rectify the US voltage, actually gets up to 160 or 170 volts or something. Let's put another motor here. Yes, here's the next motor. It's from a hairdryer. This actually run on low voltages. And I just remove the rectifier because I don't want that to blow up. And it's going on low voltages, so on 12 volts if it actually starts. It actually walks away, as you can see. I'll put it back. Actually, the tape is actually hitting the table. Let's try to crank it up to 40 volts and see what it does. And see if the neighbors get angry, because it's pretty late. It wants to walk away. Oh, come back. I don't want to blow my fuse. Look at that. It actually turns around. Let's try 70 volts. Want to have a little flight show. Next test. Magic smoke. Smells nice. Nothing happens. Let's discharge it. Turn power supply off. Still rotating. And the inductor looks a bit hot. Yeah, squishy. Did I blow the inductor? Maybe I did. Let's try without the inductors. Now it's actually bypassed that inductors, so let's try it out. No, it's done. I popped it. Let's do a quick autopsy. I think someone had a bit too fun. Somebody blow the fuse. Damn it. So I think that this motor eventually got short-circuited. Let's open it up. Let's see if the rotor is shorted. Yes, there's the brushes. Let's get this little rotor out, which is badly stuck. Yes, here you can see something. Let's get it all the way out. So here's the rotor. And there's a little interesting thing. I thought it was still rotatable, but actually a wire has got off. As you can see here, the little wire of that extremely high power centrifugal force, and it got shorted out the actual housing. It's coming off now, and that just blow the fuse. And if you can see here, The commutator is a bit carbonized, so that got really hot. So there's the magnets. Brushes looks a bit dirty as well. Thanks for watching. And I changed the fuse. There's a new fuse in it now.